Section 5.1, Angles of a Triangle. Essential question, how are the angle measures of a triangle related? Can I find the interior and exterior angle measures of triangles? All right, let's take a look at some vocabulary on classifying triangles by sides and classifying triangles by angles. You may have already seen these. In your notes, if you will just take a few minutes to write down the words, and if you need to draw a picture for yourself, but if you don't, just go ahead and list the different triangle names. Okay, let's go ahead and draw an obtuse isosceles triangle. So obtuse means I will make sure that there is an angle that is larger than 90. Isosceles means I want to make two of them the same, and then I can make the third one. So this is an example of an obtuse isosceles triangle. Let me change the color. And now I want an acute scalene triangle. Scalene means all the sides have to be the same, and acute will mean that all the angles have to be less than 90 degrees. So let's see what I can do. So I tried to make all the sides different lengths, and all the angles are going to be less than 90 degrees. All right, let's classify this triangle by its sides, then determine whether it is a right triangle. To do this, we need to find distance PO, and you can use the distance formula for that, distance OQ, and distance PQ. Now that'll help you figure out how to name it by its sides. Now to determine whether it's a right triangle, you're going to have to find some slopes. For example, find the slope of PO and find the slope of OQ. And if those end up being something that gives you some information, fine. If it doesn't, then you can go ahead and try to figure out the slope of PQ. Now, in order for it to be a right triangle, we need to see some perpendicular lines. Now, stop the screencast, see if you can figure out all these values, restart it, and you'll see the answer. Here's the answer. I found every single distance. One distance was root 50, another distance was root 5, and another distance was root 45. They're all different numbers, so I'm going to have to call this a scalene. Now, to figure out whether it's a right triangle or not, I had to find the slopes. This slope was -2, and this slope from O to Q was 1/4. It looked to me like it might be perpendicular, but now I see that they're opposite reciprocals, so I definitely know these are perpendicular to each other, which means I can call this a right triangle. Okay, our triangle sum theorem. You may already know this. The sum of the measures of the interior angles of a triangle is equal to 180. What you don't know is the proof, so let's take a look at the proof. All right, here is a triangle. We're trying to prove that this triangle with angles 1, 2, and 3, we're trying to prove that all three of these angles add up to 180. And this is how we're going to go about doing it. These three angles, let's go ahead and discuss them. First, we're going to put 3 and 4 together. We're going to call it ACD. That's this right here, ACD, plus angle 5 is equal to 180 because that's a linear pair. Now we're going to take ACD and we're going to put it into its parts, which is measure of angle 3 and angle 4. And then I'm going to substitute. That's what this is, substitute. So I have all three of these angles equaling 180. All right, now I have the angle 3, which I want angle 3 in my answer, so I'm not going to worry about that. I'm going to be looking at another way to write angle 4. Now I notice these lines are parallel, right here, parallel. So I know that angle 4 has to be congruent to angle 3. So angle 4 has to be congruent to angle 2, which I say in line 2, because if two lines are parallel, alternate interior angles are congruent. Okay, now I also see that these angles are going to be congruent, and that's what I have here. And that's because if two lines are parallel, corresponding angles are congruent. So I'm going to take angle 5 out, and in its place, I'm going to write angle 1 after I change the congruence to equals, and then I'm going to take angle 4 out, and I'm going to replace it with angle 2 after I do this line where I change them to equals, and that's how the proof is done. So if all three of these add up to 180, then all three of these will add up to 180 because of the situation with parallel lines. Okay, the exterior angle theorem says this, that angle 1 is equal to this angle plus this angle. All right, let's go ahead and go through the proof and see if this makes sense to us. Now we know that all three of these angles, this one, and this one, we know they all equal 180. We also know that these two angles right here form a linear pair. So we know they equal 180. So I'm going to put like a little double here. So I know this angle and this angle add up to 180. So we have two 180s. And I'm going to use the transitive property and make this equal to this. Okay, and I notice that they have the same angle on the left-hand side and the right-hand side of the equal sign, so I'm going to subtract them, and then I'm going to get these two angles right here equal to the exterior angle. Okay, let's look at the theorem one more time again and see if this makes sense. Okay, the exterior angle is equal to the sum of the non-adjacent interior angles. Non-adjacent means not touching angle 1. This is an adjacent interior angle where these are non-adjacent. See, it says non-adjacent. All right, let's go ahead and do a problem. All right, so this is the exterior angle. And this is this one and this one are non-adjacent interior angles. And the theorem says that the exterior angle is equal to the sum of the non-adjacent interior angles. So here's our equation. So x is equal to 75. Now it asks me to find J, K, M. So I'm going to take 2, multiply it by 75, multiply by 75, and then subtract 5. So this is 150, take away 5, so this is 145. So this angle is equal to 145 degrees. Okay, the corollary to the triangle sum. Corollary is another word for theorem, but it's a theorem that's easily proved from a big theorem, and the big theorem we're using is a triangle sum. So this little theorem, corollary, says that these two angles right here add up to 90. And that kind of makes sense because the three angles, angle A plus angle B plus 90 is equal to 180. And if you use subtraction, you're going to get the two angles equaling, the two angles equaling 90. And that's why we call it a little theorem, because it got proved so quickly. Okay, I'd like you to take a minute to stop the screencast and see if you can figure out the measure of angle 1 and if you can figure out the measures of these two acute angles. And here's the answer. I used the exterior angle theorem, and I made the exterior angle equal to the sum of the two non-adjacent, did my algebra, got x is equal to 25, and then once I got x equal to 25, I got this angle to be 75, and the three have to add up to 180, so there's only 65 degrees left for angle 1. Here is the corollary of the triangle sum theorem. I know that these two have to add up to 90. I get x equal to 32. I put 32 into here, and I get 26 degrees. I put 32 in here, and I get 64 degrees. Okay, last problem. See if you can do the problem. Stop the screencast and see if you can figure out what x and y are. And here are the answers. What I noticed is I had two parallel lines, so I knew that alternate interior angles are congruent, so I knew angle 43 and x were the same. So that was one of my answers to find x. And I knew that these two angles are a linear pair, and I know they added up to 180, so that's how I got 105. Now I know that these three angles from the triangle sum, these three angles have to add up to 180, so y is equal to 32. And that's the end of the screencast.